Hello, Kinesiology 3010. Now we're going to go into our second part of Chapter 3, Descriptive Statistics. And we're going to go into some more detail into the different variables, different values that we're going to be using for this course. So first off, we got to start with our notation. You need to understand what these symbols mean, because in our analyses, you're going to need to look at these symbols. They'll be in the mathematics equations. You need to understand what they mean. So that you can read the equations we'll have to use in this class. Sigma here, this notation here, is read as sum of. A sum of, we are adding all of those values together, the sum of all of those values. A x is an observed score, so this is a variable in most cases. N is the total number of observations, so the total number of variables that we collect, or the total measurements within one variable. And then sum of x would be the sum of x values, or the sum of those individual variables. So the sum of x would be the sum of variable 1 plus variable 2 plus variable 3 plus variable 4, and so on and so forth. Sum of x squared would be the sum of squared x scores. So this is the sum of each variable squared, individually squared. So this we write it here as sigma x squared. So this is the sum of squared x values. Okay, so this would be maybe value 1 is, or the first value is 1 squared plus 1 squared plus variable number 3 is 2 squared. So 1 squared is 1, 1 squared is 1, 2 squared is 4. We add them together. The sum of squared x scores is 6. Here, this variable is different. Okay, we have our parentheses here, and our squared is outside. This is the sum of x quantity squared. Okay, so we sum all x values and square that final value, or we square the total sum. So all values added together, we find a value. So 1 plus 1 plus 2 gives us 4. That 4 squared is 16. Okay, so this is the sum of x quantity squared. Okay, we write it here this way. Sum of squared x scores and sum of x quantity squared are different. Okay, so notice this difference, star this difference. You'll need to know it for our examples. Okay, so like here we have 3 values. We have variable 1 gave a measurement of 1, variable 2, or the second participant, maybe variable 1, and this variable is 2. The sum of x, or the sum of the variables, is 4. The sum of x squared would be each individual variable squared, then sum those together, or add those all together. Sum of x quantity squared, we would sum all the variables and then square that sum. Okay, so we see those differences here. You'll need to know that when we go through some more of our descriptive statistics, especially when we go into variability. So we'll start here with central tendency. A central tendency is our description of how close those scores are to the middle, or what is most occurring, what's most frequent, what happens the most, what's the things like average, okay, things like mean, median, and mode here. Okay, so these describe the middle of those scores. So like the mean value for the midterm test, or the average. Okay, what happens? What is the average of those scores? So putting all those scores together, what's the average? So what's in the middle? Okay, our measurements. Central tendency is measured here with mode, median, and mean. Mode is what happens most frequently. Median is our 50th percentile, so 50% above, 50% below, and then mean is our average. Okay, so mode, most frequently occurring score. Okay, remember back to our frequency table. It's really easy to find our mode when we create our frequency table. Okay, and there can also be more than one mode. We can have a bimodal, so 2 different modes, or 2 scores that occur most frequently. They both occur, say they both occur 10 times, and that's the most of all those values. It would be a bimodal distribution. So 2 different variables that both occur the same frequency, or the same amount, and it's more than all of the others' frequency. And then we notate mode with capital M, lowercase o. Okay, so that's our mode. or the most frequently occurring scores. So let's do a little example. Okay, what's the mode of this data set? Okay, just looking at it, you might want to just count each one. It's a little bit easier if we just create a frequency distribution table. Okay, we look at each score, see how many times each one occurs. Now, what is the highest frequency? That's right, 6. So which score occurs a frequency of 6? 4. Okay, so 4 is the mode or the most frequently occurring score. It's also easy if we graph this. Okay, this is a frequency graph. Okay, we have a bar graph version here. Okay, so score of 1 occurred 1 time, score of 2 occurred 2 times, score of 3 occurred 4 times, 4 occurred 6 times, and 5 occurred 2 times. So we know that the largest bar is our mode or most frequently occurring score. When we go to median, median is our 50th percentile. Okay, so this means that we are directly in half. Okay, 50% above, 50% below. So if we have scores that are below the median, we'll have half of the total distribution will be below, half will be above. Okay, so this is our most consistent, this is our best measure for central tendency because it is the very middle. It is the 50th percentile. We know that half are above and half are below, especially if we're looking at very skewed distributions where a lot of scores are occurring on one side and a few are occurring on the other side. This central tendency gives us the very middle of all of those scores. It's our best central tendency measure. And then we notate that as capital M, lowercase d, lowercase n. So that would be our median or our middle 50th percentile. Okay. When we have an odd number of variables or an odd number of values, the median is the single middle value. And in order for us to calculate this, we do need to order them from lowest to highest or highest to lowest. If we have an even number of values, or our n, our total number of variables, is even, we take the two middle values. So say we have 6 scores, score 3 and score 4. If we order them, the third score and the fourth score, we will average those two to find the median. Okay, so the average of the two middle scores becomes the median. So now 3 will be below and 3 will be above. So our median doesn't have to actually be a discrete value that's in our distribution. It has to be the middle where half are above and half are below. Okay, for us to calculate it, we can do the counting method. So we can count the top, count the bottom, and we can also find where that is. So you could just count how many you have and count your way up to the middle. But if you want to find its location a little easier, take our n, or our number of values, plus 1. So if n is 6 plus 1, that would be 7. Divided by 2, that would give us 3.5. So at 3 and 3, and then halfway between those are the average of those two, just like we did before, would be our median. Okay, so to find it, we need to look at how many numbers we have. If it's odd, we have an exact value. If it's even, we have the average of the two middle scores. So let's do a little example. So we want to find the median of the scores here. N is odd because n is 7. 7's an odd number. So we know that it has to be in the middle here. So we can just count 1, 2, 3, 1, 2, 3 right here, or we can use our calculating method. 7 plus 1 divided by 2 would give us 8. So 4 scores down right here would be 7. So 3 and 3. There we go. Okay, so there's our location, or we can count from the bottom, either one. But our median is still 7 in this distribution, half, half in the middle. Okay, if our median, or if our n is odd, or n is an even number, like 6, okay, we will calculate 3.5. That tells us that 3.5, it has to be the average of those two middle scores. So in this case, 10.5 would be our median because it's between, it's the average of those two middle scores. Okay, so here's another example. 8 plus 1 divided by 2 gives us 4.5. 1, 2, 3, 4, or 1, 2, 3, 4. What's in between those two scores? Okay, the average of 10 plus 10 gives us 10. Okay, so the median is 10. So now we'll go on to mean. You've probably done a lot of these, probably in algebra or whatever you did probably previously in your educational career. But mean is the average of the set of scores. Okay, so it's most used, it's often used, but it's affected by skewing. So if we have a large number of values on one side, so we have a big cluster at maybe the higher level, and then we have a few really far down, really low level, it can be very affected. But it's best for our interval and ratio scale numbers because it's going to tell us what's in the middle or what's near the middle of that distribution. And our notation here, so the mean or the average of the population is mu. Okay, this value here, it looks like a U with a tail on the front. That is mu, that is the mean or the average of a population. So a large population, like all of the United States, but we can't test all of the United States on one of our values. So we'll use what's called a sample. So we'll take a piece that should describe the larger population, and the mean of a sample is an X with a bar above. Okay, this would be how we would symbolize it. So X with a bar above. So we have that right here. How we calculate the mean is the sum of the variables divided by the number of variables. It gives us the average score. Okay, so sum, remember sigma here, sum of X scores, or is the sum of the variables. Okay, sum, if we take our variables, we have our sum here is 8, our total frequency, and then we know that the product of the frequency and the scores, so how often it occurs multiplied by the value. So 10 occurs one time, 1 times 10 is 10, 2 times 9, 18, 4 times 8, 32. It helps us get to that sum a little quicker. If we go this way, 0 times 7 is 0, 1 times 6 is 6, and we can add those scores together, we get 60. Okay, if that went a little bit fast, we'll go back through that. So our scores that are available, our values, the frequency that they occur, the amount of times that they occur, and then the product or the multiplication of the frequency and the score will give us the total amount. Okay, so in this case, there would be 1 10, 2 9s, 4 8s, 0 7s, and 1 6. If you added all those together, you would still get 66. It's just a little quicker here if we do it like this with our frequency table. So in this case, the average or the mean of this test, or with all of our measurements here, would be the sum of X, 66, divided by N, or 8, gives us 8.25. That is the middle of that distribution. If we look here, the mode of these scores would be 8. So we're probably pretty normal because we see that there is an average or a mean that's similar to our mode. Okay, if we look at SPSS, this is our statistical software. We won't use it for this class, but I'll use some examples because if you go on in kinesiology, you'll probably end up using this software. So we have all of our scores here. N is 15. We have 15 total scores here. We can calculate using statistical software. It can take care of it for us. The mean of these values is 3.4. The median is 4 and the mode is 4. I want you on your own to go through and create your own frequency table and calculate the mean, median, mode. Or you could use this frequency table that's here for you, but you should try to do it on your own and practice on your own. But this is an example that you can do on your own and check to see if these are correct and make sure that your math is correct when you go through this. Okay, now when we graph these numbers or graph these variables along a curve, we can tell if they're normal or have this bell shape, or if it's positively skewed, we have a few numbers that are positive that are pulling forward, or negatively skewed where things are pulling downward. A key here, we'll talk about a little bit more in a little bit. Negative skew, you follow the tail. Positive skew, you follow the tail. So where that kind of tails off, if it tails off towards the negative or tails off left, it's negative. If it tails off positive or towards the right, it's a positively skewed. If it's even, it's normal. Okay, so normal distribution is a bell-shaped curve where most of the scores occur right in the center and fewer occur on each side. This is one of our inferences with statistics, is that population should be normally distributed, where most are in the middle, a few are on the bottom, a few are on the top, but most scores, the average, the median, the mode, all really occur in the same point. On a perfect normal distribution, the mean, median, and mode will be the same value directly in the middle of this curve. So 50% will be above, 50% will be below. When we have a skewed score, so here the tail goes positive, this is a positively skewed distribution. If the mean is above, okay, so the mode is on the opposite end of the tail, and say the median is our middle. If the mean goes towards the tail and it's positive, it's a positively skewed value. Okay, if these were flipped, if the mean was pulled down below the mode, okay, and the median, or below the median and the mode's on the other side, we know that it's a negatively skewed value. I'll give us another example here. So here's a positively skewed distribution. Okay, we would have here our midline or our median, where 50% of the scores are on the right, 50% of the scores are on the left. If we look at where the top of the curve is, the top of the curve tells us the mode, or the most often, because this is a frequency distribution curve. Okay, the mode here is right where it's occurring the most often. The mean, or our average, is pulled positive. Okay, is pulled positive in this case. Okay, so if we have a median that has a mean that is above and a mode that's below, we have a positively skewed distribution, which means that most of the scores are on the low end, but a few high scores have pulled the average up. A few high scores pull the average up and positively skew the average, okay, or make the average larger than what is actually the true normal for this situation, or what is 50th percentile. If we look at a negative skew, this is the opposite. Okay, our median's here in the middle. This is our 50th percent, 50%'s above, 50% happens below. Our mean is pulled below, or our mean is less than our median, and our mode is greater. We know that that tail's going left. That's a negatively skewed distribution. So that means that most scores are on the high end, but a few low scores or extremely low scores have pulled the mean or pulled the average lower than what is truly 50-50, what is truly in the middle. Okay, so here's another example. If we look at bowling scores, if you've ever been bowling, I wish we could still go bowling right now. But we look at kind of these ranges of scores, look at the frequency within those ranges. Okay, we have our 100th percentiles up here at the top, and we go down and down and down. I'm giving you the percentages and the percentiles for you. But is this normal? Okay, that's what we have to ask ourselves. Is this a normal distribution? Because if it's not a normal distribution, we probably can't use most of our inferential statistics, which we'll go into in our next section. Okay, so think, is this normal? If we graph the frequencies, okay, graph how often each occurs, and chart it here, this looks relatively normal. Okay, the mode's pretty much in the middle, and we don't really have a tail that's taking us either way significantly. Okay, so I would call this a normal distribution. Now, if we look at this skin fold test, and we're looking at each of these skin fold values, okay, and how often they occurred on our distribution, what kind of skew would we see here? Okay, we see the mode here. If we took 50-50, it would be probably around here in the middle. And then we see these really high scores that are pulling our average forward. If you calculated the average, you would find that it is pulled more positive. If the tail goes right, the average is greater than the median, the mode is less than the median, we know we have a positively skewed distribution, because a few positive numbers or a few greater numbers pulled the average higher than what is truly in the middle. Okay, so here's a check for understanding. You can think through this one a little bit. Okay, so if most students in the class pass a test, a pass as in above 60%, so most, the mode, okay, most students pass the test with a mean score, but the mean score of the exams was 65, which is not passing or less than passing. What kind of distribution would we have if most of the scores, okay, so greater than 50% mode is above or passing, but our mean, our average is less than passing? That would mean we'd have a what? Negatively skewed distribution, because in this case, a few low numbers pulled the mean below what is normal or what is most frequently occurring. Right? I hope that made sense. We'll go through this a few more times. We'll keep going through them. If you need more help, you can always email me, set up office hours, or review these video lectures. That's why I like the video portion. You can pause, replay, and go through them over and over. Thank you very much for watching, and I look forward to our videos next week.